Hello, so today we're going to be extending what we've learned about expanding and condensing logs and solving exponential functions that you can't do mentally, okay? So logs and exponential functions that you can't do mentally. All right, so let's warm up by looking at, we're on page 14 in your note packet. So log base 2 of the cubed root of 2. We've done these, and I said the easiest way is to set it equal to a variable. The variable I often use is k. So I would rewrite it exponentially, 2 to the k equals 2 to the 1/3. 2 to the k equals 2 to the 1/3. Then I get to use Coach Fred's favorite law. The bases are the same, we cancel, and we can say that the powers equal each other. So k equals 1/3. So evaluating that log mentally is 1/3. That log equals 1/3. All right, let's try it again. We have 3 to the of 1/8, log base 3 of 1/8, 181. So I'm going to set it equal to k. I'm going to write it exponentially. So 3 to the k equals 1 over 81. I have to do a little bit more work. I have to remember that 81 can be written as a base 3 number. So it can be written as 3 to the k equals 1 all over 3 to the 4. Well, I have to remember also that if I want to use Coach Fred's favorite law, I can't have it as a fraction on this right side. So I have to bring that 3 to the 4 up. To bring it up means I have to kind of work backwards with the negative exponent law. So it would be 3 to the k equals 3 to the negative 4. Bases are the same now, so k equals negative 4. All right, here's another one. 2x to the 16. This is an exponential function. So how do I solve it? Or an exponential equation. I solve it by making these bases the same. So 2 to the x equals 2 to the 4. The bases are now the same, so x equals 4. So you guys have done a really nice job with that. But now, what happens if I give you 5 to the x equals 7? How can I make 5 to the x equal 7? So this is a place where I have to use logs. Okay, I have to use logs. How do we undo an exponential function? Well, let's review how we undo other functions. We undo addition by using subtraction. We undo multiplication by doing division, or vice versa. We undo an x squared by taking its square root. We undo x cubed by taking its cubed root. We undo an exponential function by using its inverse. These are all inverse functions, so we use the logs. Or also remember, or ln. Okay, so the inverse of an exponential function, which we have talked about, is a log. It's the log function. All right, so how are we going to use this? So if I give you 2 to the x equals 15 and you're unable, you first want to see if you can make the bases the same. If you can't, then what you would do is take the log of both sides. Remember, you're able to do this because whatever you do to one side, you do to the other. All right, so we do log 2 to the x equals, we write the word log right in front of the number. So that means taking the log of both sides. Okay, so now we can use our laws of our expansion laws. I see that power of x, I can bring it into the front. So now I have x log 2 equals log 15. All right, so now I can solve for x by dividing both sides by log 2. Now, you have to be really careful here. This is not the same thing as log base 15 over 2. Okay, that and this are very different. This is an entire log. Divided by an entire log. Now, we grab our calculator and we can put this right into the calculator. And again, you can't write this as log 15 divided by 2. You have to do log 15 divided by log 2. Okay, so let's try that. Get the calculator open, grab yours if you have them. All right, let me clear everything out. So I'm going to do, here's the log button, first column, midway down, log 15. I'm going to close the parentheses, divided by log 2. Now I'm able to put these both into the calculator because they are base 10 numbers. We can only use this log button if they are base 10 numbers. So rounded to the nearest tenth, x is approximately 3.9. All right, let's try it again. We look at 6x equals 9. I know you want to have a tendency to see that they're be able to write them as the same base, but you can't because 6 cannot be written as a base 3 number, okay? 3 to the 2 is 9, 3 to the 1 is 3, so I can't write 6 as a base 2 number. So this is where I have to use the logs. So I would do log 6 to the x equals log 9. All right, so I bring the x to the front. So x log 6 equals log 9. I'm going to divide both sides by log 6. Now you may notice when you take the log of both sides, you're taking the base 10 number, so you're making it calculator ready. So now I grab that calculator and I'm going to do again log 6 or log 9. So log 9 divided by, oops, and actually I want to make sure I close the parentheses. Look what I did there. Log 9 divided by log 6. And I forgot my space, I forgot my division. So log 9, close parentheses, divided by log 6. And I'm going to close it just to be neat. And we get 1.2. So x is approximately 1.2. Okay? All right, you try the last one, okay? You try the last one. 4 to the x equals 19. All right, so try it and come back. All right, so what you should have done was log 4 to the x equals log 19. You should have brought the x to the front. So x log 4 equals log 19. And then divide by log 4 on both sides. So you would have gotten log 19 divided by log 4, which would have given us 2.1. It's not that hard of a process, but it's just going to take you some practice. And remember, no matter what, if you can make the bases the same, that's the easier way. All right. Now what if, so this is something different. What if you're given a log and you want to evaluate the expression with your calculator? Meaning you can't evaluate it like we did in examples 1 and 2 above. What base does it have to be if you're going to use your calculator? I hope I hear all of you saying it has to be base 10. Well, what if it's not base 10? What can I do? When can I use a calculator to evaluate a log? Well, it has to be base 10. That's the most important thing. Well, there is a way for you to change a log, an expression of a log, into calculator-ready form. It's something called the change of base formula. If you're given log base b of x and it's not a base 10 and you want to put it into your calculator, you can actually do the log of x over the log of b. Okay, so here's an example. I want to evaluate log base 3 of 16. Well, I know that if I set it equal to k, I get 3 to the k equals 16. I can't turn these into the same bases. So I can go through that process I just did to solve it, or I can look at it and say, let me just use the change of base and evaluate it with my calculator. So I can do log 16 over log 3. So log 16, grab the calculator, divided by log 3, you get 2.5. All right, try another one. Log 25 over log 9. Changed it to log base 10. So now I can do log 25 divided by log 9, making sure I close those parentheses, and I get approximately 1.5. All right, so what I'd like you to do is I'd like you to try log base 2 of 5 and log base 2 of 20. Okay, so if you just did those, you did log base 5 over log base 2, and you got log base 5 divided by log 2, and you got 2.3. This one, you changed log base 220 into log 20 over log 2. Be really careful. Remember, you're not allowed to divide using the change of base. This does not mean log 20 divided by 2, okay? It does not mean that. You have to use your calculator as separate logs. So log 20 divided by log 2, which gives me 4.3. Okay, so those are two things that are going to be really important, solving a log equation and the change of base. What I'd like you to do now is I'd like you to go to the next page where it says solving more difficult log equations. The warm-up is page 15. So I'd like you to do the problems on page 15 and bring to class tomorrow. We will check. There is also a bonus opportunity. The bonus opportunity needs to be done by you alone, not by a calculator, not by a computer, not by an app, not by your friend. It needs to be done by you. So I hope we all are following our great honor code. Thanks so much, guys. Have a great night.